Chapter 14 of the guided notes. This is a new chapter. We are moving from geometry to geometric sequences. You already have some experience with sequences. We did them in the beginning of the year. And geometric sequences are similar to arithmetic sequences, which is what you worked on last time. But they're also slightly different, and we're going to explore that today. So an arithmetic sequence, if you recall, if I had an arithmetic sequence, and I was given a list of numbers like 4, 20, 100, and 500, I would try to figure out, well, what's 20 minus 4? That's 16. And what's 100 minus 20? That's 80. And what's 500 minus 100? That's 400. And when you were working on arithmetic sequences, this number wound up being the same, right? A common difference. That's what you were looking for in arithmetic sequences, a common difference. And this should be like bringing back memories or nightmares for you. We represented the common difference by D, right? We were always trying to find out what D was equal to. Now you can see immediately in this particular sequence, and that sequence, all that is a list of numbers in a specific order, there's not a common difference, right? 16 is not the same as 80. 80 is not the same as 400. So the common difference is not so common. So this is definitely not an arithmetic sequence. It is, in fact, a different type of sequence, and the one we are going to talk about today. It's a geometric sequence, and here's the difference. A geometric sequence has the ratio. The ratio of successive terms is constant. Now, when you were working on arithmetic sequences, it was the difference of successive terms was constant. So that's one major difference. Now, difference has to do with like subtraction, right? Ratio is division as opposed to subtraction. So the common ratio is the name of the constant ratio, not ration. The common ratio, often represented by R, right? Instead of D, now we'll be looking for R. So instead of multiplying these terms on a geometric sequence, we divide. So what is 20 divided by 4? It's 5. How about 100 divided by 20? 5. Oh, look. Right now, this is sort of making sense, I hope. What's 500 divided by 100? 5. Now we definitely have something in common between the terms, right? And hopefully this will refresh your memory too. This first term, that's f of 1. This second term, f of 2. Hopefully you can read that. This third term, f of 3. The fourth term, that's f of 4. Right? So if you're given, like you might be, hint, hint, on a future quiz, give me f of 1 of this geometric sequence, you should definitely get this right because it's going to be the first number in the list of numbers. So we have now found R. Instead of looking for D, geometric sequence, we find R, which represents our common ratio. And R in this case is 5. So basically every single term, every successive term is going to be multiplied by 5, or going backwards, divided by 5. So the next term is going to be, that's going to be f of 5, right here, f of 5. And what is 500 times 5? 2,500. And f of 6 is going to be 2,500 times 5, 12,500. F of 7 is going to be 12,500 times 5, 62,500. So you're probably going to need a calculator for this section. Just heads up. You should grab one. Now let's look at this next example. So, all right, if this were a arithmetic sequence, when I do that, that means you like subtract the 2, but it's not. It's a geometric sequence. So we're going to have to do, we're going to have to divide. So what is negative 36 divided by 72? And you're going to find it's equal to a negative 1/2. And you're going to find the same thing. 18 divided by a negative 36 is going to equal a negative 1/2. And then negative 9 divided by 18 is going to equal a negative 1/2. So hopefully you can recognize, right, our common ratio is negative 1/2. And so here was f of 1, f of 2, f of 3, f of 4. Here's f of 5, f of 6, f of 7. So to find the next 3 terms, right, you're going to have to take you basically negative 9 and times it by a negative 1/2. And that's going to be a positive 4.5. The next term times the negative 1/2, negative 2.25. And then the next term times the negative 1/2, 1.125. So hopefully this is starting to make sense. Let's take a look at some rules that we can develop for determining terms in a geometric sequence. I'll give you a moment or so to write that down. Okay, so I'm going to basically just call out right now the 2 rules, and you should hopefully remember these. We had recursive rules. The recursive rule for an arithmetic sequence, I think there's still posters up on the wall for that, for an arithmetic sequence, and then we also had explicit rules. Now for, in both of them, you need to know what f of 1 is. So f of 1 is definitely equal to something. Hopefully you can identify the first number in the list of numbers. The next thing, for recursive rule at least, you have this part of the formula. F of n is equal to, I'm going to change colors here, f of n minus 1 times r, and r is our common ratio. And for explicit rule, you have f of n is equal to, let me mix up the colors a little bit, basically f of 1 times r to the n minus 1 power. So that might seem a little goofy. You guys don't have a lot of experience, at least in this class, with exponents yet. But that's the recursive rule. Now you remember when we were doing arithmetic sequences, and if you can find the poster up in the wall, right, you still had to know what f of 1 was, and then you had to figure out d. Well, this is almost like the same thing. You still have to find out f of 1, but now you got to find out r. So I hope that this is starting to make sense. And let's do 2 more examples before moving on to the homework packet. So we're going to not do this example because it's like I just don't like that example. So let's do this other example though. Let's find the common ratio between these terms. So I'm going to find out, well, what happens when I take a negative 12 and divide it by the first term. If I take the second term and divide it by the first term, you should get a negative 4. And hopefully, when I take the third term and divide it by the second term, I get a ratio that is common, and you also get negative 4, right? They're both the same. So we definitely have a ratio that is common, and that ratio is -4. Now, if I wanted to find the sixth term using the recursive rule, right, I have to, just like you had to multiply this by -4 to get -12, and then that by -4 to get 48. Here's f of 3, you'd have to do it for f of 4, and then f of 5, and then f of 6. You'd have to multiply it 3 more times. And that's totally reasonable, right? We can take, if we already know f of 1 is 3, f of 2 is -12, f of 3 is 48, f of 4, 48 times -4. So you're going to definitely need your calculator, right? That's -192. And times a -4. $768, and then times a -4, 768 times a -4, -3072. So that's the recursive way. What if I asked you though to, on a test, give me the, I don't know, 32nd term? How much time do you think you have on the test? You're going to be able to multiply that out 32 times? Maybe, but what if I give you, 10 of those questions, right? So, the recursive rule works for if you have lots of time, and the explicit rule gets you the same thing but faster. So let's try to work with the explicit rule. I'm going to use the explicit rule over here, and we're just going to pretend like these numbers don't exist here. So here was recursive, and this same sequence for explicit. And let's see, we know f of 1, right? What's the first number in the list of numbers? At least if we're talking about this sequence over here, it's 3. And so let's plug in the formula. It's basically going to be 3, which is what f of 1 is equal to, times r. We know r is -4, times n, or to the n minus 1 power. To the n minus 1 power. Well, you already know your n. You're trying to find the sixth term. So what is 6 minus 1? Right? This goes 6 minus 1 here. That's 5. So you're going to go 3 times a -4 to the 5th power. And that's going to equal whatever the sixth term is. Now, I'm going to take a moment to show you where the power key is at on your class set of calculators. And hopefully you can key this in and also find the sixth term. Now you're wondering, if I'm finding the sixth term, why is a 5 right here? 6 minus 1 is 5. That's the work we did just up above. 3 times a -4 raised to the 5th power, and voila, we should get the same answer. So this is the explicit way. And from here, let's go to the homework package.